This is SpaceTime, Series 28, Episode 101, for broadcast on the 22nd of August 2025. Coming up on SpaceTime, did a comet trigger Earth's younger Dryas cool-off? The discovery of a rare white dwarf merger remnant? And China tests its new manned lunar lander. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has raised serious questions as to whether a massive comet may have triggered planet Earth's younger Dryas cool-off event. The massive climate change is generally thought to have been caused by glacial meltwater. But analysis of ocean sediments reported in the journal PLOS One are suggesting geochemical clues in line with the possibility that an encounter with a disintegrating comet 12,800 years ago may well have triggered rapid cooling of Earth's air and oceans. The study's lead author, Christopher Moore from the University of South Carolina, says that during the abrupt cool-off, the younger Dryas event, temperatures dropped by around 10 degrees Celsius in a year or less, with cooler temperatures lasting for some 1,200 years. Many scientists believe that no comet was involved and that it was glacial meltwater in the northern hemisphere causing a freshening of the Atlantic Ocean, significantly weakening currents that transport warm tropical water northwards, such as the Gulf Stream. Now, in contrast, the younger Dryas impact hypothesis proposes that Earth passed through a debris trail left from a disintegrating comet, with numerous impacts and shockwaves destabilizing ice sheets and causing massive meltwater flooding, which then shut down key ocean currents. However, the impact hypothesis has been less well supported, lacking any evidence from ocean sediment. Now, to address this gap, Moore and colleagues analysed the geochemistry of 4 seafloor cores from Baffin Bay near Greenland. Radiocarbon dating suggests that the cores include sediments deposited when the younger Dryas event began. To study them, the authors used several techniques, including scanning electron microscopy, single particle inductivity coupled with plasma time-of-flight mass spectrometry, energy dispersive spectroscopy, and laser ablation inductivity coupled plasma mass spectrometry. The analysis detected metallic debris whose geochemistry would be consistent with comet dust. These occurred alongside microscopic spherical particles whose composition indicates a mostly terrestrial origin, with some materials believed to be extraterrestrial. That suggests these microspherules could have formed when cometary fragments exploded just above or upon hitting the ground, melting materials together. The analysis also uncovered even smaller nanoparticles with high levels of platinum, iridium, nickel and cobalt. And these can all be signs of extraterrestrial origin, especially iridium, which is rare on Earth but common in asteroids and comets. Together, the findings indicate a geochemical anomaly occurring around the time that the younger Dryas event began. Of course, they don't provide direct evidence supporting the impact hypothesis. More research will be needed to confirm whether the findings are indeed evidence of an impact and to firmly link the impact to climate cooling. Moore says identification of a younger Dryas impact layer in the deep marine sediments underscores the potential of oceanic records to broaden science's understanding of this event and its climatological impacts. He says the data suggests that the amount of comet dust in the atmosphere was enough to cause a short-term impact winter, followed by a 1,400-year cooling-off period. This is SpaceTime. Still to come, discovery of a rare white dwarf merger remnant. And China tests its new manned lunar lander. All that and more still to come on SpaceTime. Astronomers have discovered a cosmic rarity, an ultra-massive white dwarf star resulting from a white dwarf merging with another star rather than through the evolution of just a single star. The discovery, which was made possible by NASA's Hubble Space Telescope's sensitive ultraviolet observations, suggests that these very rare white dwarf mergers may be more common than previously thought. One of the study's authors, Boris Genzicki from the University of Warwick, says the discovery underlines how things can be different from what they appear to be at first sight. Until now, this object appeared to be a normal white dwarf. But Hubble's ultraviolet vision revealed that it had a very different history from what astronomers would have guessed. Now, a white dwarf is the dead stellar core of a sun-like star. After fusing their core hydrogen into helium, they then fuse their core helium into carbon and oxygen, in the process expanding out to become a red giant. And because they're not massive enough to fuse carbon and oxygen into heavier elements, the fusion process turns off and the star dies. Eventually, they puff off their outer gaseous envelope, which gradually floats away as a spectacular, colourful object called a planetary nebula. And that exposes their white, ultra-hot stellar core, the white dwarf, a super-dense object composed mostly of oxygen and carbon, usually about the size of the Earth, which will slowly cool over the eons. Our Sun will eventually become a white dwarf when it drops off the main sequence in around 5 to 7 billion years from now. Now, in theory, a white dwarf can have a mass of up to 1.4 times that of the Sun, but usually white dwarfs heavier than our Sun are fairly rare. These objects, which astronomers call ultramassive white dwarfs, can form either through the evolution of a single massive star or through the merger of a white dwarf with another star, such as a binary companion. This new discovery, reported in the journal Nature Astronomy, marks the first time that a white dwarf born from merging stars has been identified by its ultraviolet signature. Now, prior to this study, only 6 white dwarf merger remnants have been discovered, all by their carbon spectral lines in their visible light spectra. Now, all 7 of these objects are part of a larger group of stars that were found to be bluer than expected for their masses and ages from a study by the European Space Agency's Gaia mission in 2019, providing new insights into their formation history. For this latest discovery, astronomers used Hubble's Cosmic Origin spectrograph to investigate a white dwarf catalogued as WD0525 plus 526. It's located 126 light-years away and is about 20% more massive than our Sun. Now, in visible light, the spectrum of the atmosphere of WD0525 plus 526 resembles that of a typical white dwarf. However, Hubble's ultraviolet spectrum revealed something unusual, evidence of carbon in the white dwarf's atmosphere. White dwarfs that form through the evolution of a single star have atmospheres composed of hydrogen and helium. As we mentioned earlier, the core of the white dwarf is typically composed mostly of carbon and oxygen, but a thick atmosphere usually prevents these elements from appearing in the white dwarf spectra. So, when carbon does appear in the spectrum of a white dwarf, it's a signal of a more violent origin than a typical single-star scenario. In other words, the collision of 2 white dwarfs, or a white dwarf and another star. And these collisions can burn away the hydrogen and helium atmospheres of the colliding stars, leaving behind a scant layer of hydrogen and helium around the merger remnant that allows carbon from the white dwarf's core to float upwards where it can be detected. WD0525 plus 526 is remarkable, even within the small group of white dwarfs known to be the result of merging stars. With a temperature of almost 21,000 Kelvin and some 1.2 solar masses, this object is hotter and more massive than other white dwarfs in this group. Its extreme temperature posed something of a mystery. For cooler white dwarfs, such as the 6 previously discovered merger products, a process called convection can mix carbon into the thin hydrogen-helium atmosphere. The problem is WD0525 plus 526 is simply too hot for convection to take place. So instead, the authors concluded that a more subtle process called semiconvection brings small amounts of carbon up into the atmosphere. And this object has the smallest amount of atmospheric carbon of any white dwarf known to result from a merger, about 100,000 times less than other merger remnants. The high temperature and low carbon abundance means that identifying this white dwarf as a product of a merger would have been impossible without Hubble's sensitivity to ultraviolet light. See, the spectral lines from elements heavier than helium, like carbon, become fainter at visible wavelengths for hotter white dwarfs. But these spectral signatures remain bright in the ultraviolet, where Hubble is uniquely positioned to spot them. Because WD0525 plus 526's unusual origins were only revealed once astronomers glimpsed its ultraviolet spectrum, it's highly likely that other, seemingly normal white dwarfs may actually be out there as a result of other cosmic collisions. And so, the search is underway. This report from NASA TV.
Astronomers using NASA's Hubble Space Telescope have found a rare, ultramassive white dwarf formed from merging stars. The discovery was made possible by Hubble's sensitive ultraviolet observations and suggests these unusual white dwarfs may be more common than once thought. The white dwarf is 128 light-years away and 20% more massive than the Sun. In visible light, it looked like a typical white dwarf, but Hubble's ultraviolet data revealed something unusual, evidence of carbon in its atmosphere. A white dwarf is what stars like the Sun become after they exhaust their nuclear fuel. Near the end of its life, this type of star expels most of its outer material, creating a planetary nebula. Only the hot core of the star remains. White dwarfs that form from a single star usually have atmospheres made of hydrogen and helium. These thick layers cover its carbon and oxygen, or oxygen and neon surface, preventing their detection in the star's spectrum. When carbon shows up in a white dwarf spectrum, it can point to a more violent origin, such as a collision between two white dwarfs or between a white dwarf and a subgiant star. These collisions can burn off most of the hydrogen and helium, leaving only a thin layer behind, allowing astronomers to detect carbon on the white dwarf's surface. This white dwarf's merger origin would be impossible to identify without Hubble's ultraviolet sensitivity. In hotter white dwarfs, spectral lines from elements heavier than helium fade in visible light and stay bright in ultraviolet, where Hubble can detect them. Researchers discovered this white dwarf's unusual origin by looking at its ultraviolet spectrum, suggesting that other white dwarfs with a typical visible light spectrum may also be the result of cosmic collisions. The team plans to explore this possibility further and hopes to continue this research by studying how common carbon stars are among similar white dwarfs, and how many stellar mergers might be hiding among the normal white dwarf family. This research will help improve our understanding of the environments in which stars evolve and the paths that lead to supernova explosions.
This is SpaceTime. Still to come, China tests its new manned lunar lander, and later in the science report, researchers have developed new solar-powered floating devices so light they can support instruments high up in the atmosphere. All that and more still to come on SpaceTime. China has successfully carried out what it claims is the first test of its future manned lunar landing craft. The China Manned Space Agency says the test flight at a facility in Hebei province included both a controlled landing and takeoff, marking a major milestone in Beijing's manned lunar space exploration program. The Lanyu, which means embracing the moon in Mandarin, is similar in concept to NASA's original Apollo-era Lunar Excursion Module, or LEM, which brought the first humans to the lunar surface on Apollo 11 in 1969. Lanyu is composed of both a landing module and a propulsion module, and it's designed to carry 2 taikonauts from lunar orbit down to the surface and back again. It also has enough room for a lunar rover and scientific equipment, again, just like Apollo. China says it plans to have its first taikonauts walking on the lunar surface by 2030 and will develop a permanent base on the moon with the Russians during the early 2030s. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. Scientists are warning that Argentina's Perito Moreno glacier, previously considered to be one of the most stable in the region, has now begun retreating faster than previously thought. A report in the journal Communications, Earth and Environment looked at a combination of satellite data, radar images from helicopter flights, and mapping of the lake bed to estimate how the glacier has changed between the year 2000 and 2024. Despite retreating less than 100 metres from the year 2000 through to 2019, the authors found that some areas of the glacier have been retreating by as much as 800 metres in recent years, with a more than 16-fold increase in thinning rates at the glacier's lowest point since 2019. The authors warn it's now possible that this glacier is following a similar pattern in other retreating glaciers around the world. Anthropologists have found that 2 different groups of Neanderthals living in 2 nearby caves butchered the same prey but in very different ways. The discovery, reported in the journal Frontiers of Environmental Archaeology, suggests that each group practiced its own unique local food traditions. These Neanderthals, who lived between 50,000 and 60,000 years ago, used the same tools and hunted the same prey. But the cut marks on the remains of their food reveal they were preparing it in very different ways that can't be explained simply by the skill of the butchers or the resources or tools that each of these communities were using. The authors say the Neanderthals at one cave may have been drying their meat before cooking it, while the other group didn't do that. Scientists have developed tiny solar-powered floating devices that could support instruments high up in the atmosphere. The devices, reported in the journal Nature, work through a process called photophoresis, in which motion is generated by heating particles suspended in a gas or liquid by exposing them to sunlight. The authors developed a new type of flying structure made from two thin perforated membranes connected by tiny vertical supports, which they say can levitate under the amount of light available at high altitudes on Earth. They're now proposing a 3 centimetre wide version of this vehicle capable of carrying a 10 milligram payload. That's enough to support a small communication system containing a radio frequency antenna, a solar cell, and integrated circuits. They say the devices have the potential to help monitor the planet's atmosphere and even help with the exploration of other planets. It seems a medieval saint may have wrongly predicted the number of popes before the end of times. Saint Malachi of Armagh, who died in 1148, is alleged to have stated in the prophecy of the popes that 110 pontiffs would reign until Judgment Day. But there may have been some confusion with the prophecy. That's because of political events within the Catholic Church which have impacted exactly how many people were anointed as Bishop of Rome. Tim Mendham from Australian Skeptics says, then again, Malachi may simply have got it all wrong.
Well, we do know about the end of the world and when it's going to happen because this saint called Saint Malachi of Armagh in Ireland made a prediction. He's from the 1100s, on his way to Rome, had an epiphany, had a moment, you think, how many popes have there been? And based on the number of popes, when you get to 111, actually he said 110, someone else added another one to it. When you get to 111 or 110, that'll be the last pope. Unfortunately, we just passed that, now to the 112th, I think.
Whoopsie.
Pope Leo. Yes, whoopsie. In other words, the headline of this story was, did a medieval saint wrongly predict the number of popes before the end times? The answer is yes. The issue is that they assume he lived. They're pretty sure this fellow was a real person, whether he was a real saint, in the 1100s. But these predictions started appearing a few hundred years later that he supposedly wrote. So he didn't necessarily write them, but they've been applied to him, and they're wrong anyway. So it might have been written during a period of anti-popery, great schism of the Catholic Church. Catholic Church can't take their sainthood away from someone, which they've already given to him, even if he got his prediction wrong. They're probably quite happy. Anyway, so the story goes, this guy made his prediction. It's unfortunately, like a lot of predictions, we've passed the time. The world hasn't ended. It is supposed to be the end times, and the whole thing comes to apocalypse and Armageddon, whatever sort of particular sort of end you're looking for. It was supposed to be the last pope. It was supposed to be Petrus Romanus, which is Peter the Roman. He's identified as the final pope, and the story goes, in the final persecution of the Holy Roman Church, there will reign Peter the Roman, who will feed his flock amid many tribulations, after which the seven-hilled city will be destroyed and the dreadful judge will judge the people, the end. So they haven't got a pope called Petrus or Peter or the Rock, and therefore, whoopsie, as you say, the prophecy has not come true and probably won't come true.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.